Alright, welcome. This is 6.1, the polygon angle sum theorems. So we are going to our objective is to find the sum of the measures of interior angles, so inside the polygons, as well as exterior angles of the polygon. So I have that header at the top, and we'll write down some key concepts really quick. So our first key concept, you're going to write this down, is the angle sum theorem. And so the angle sum theorem is that the sum of the interior measures of the angles, so the insides of the angles of an n-gon is n minus 2 times 180. So any type of polygon that we have, whether it's a hexagon, octagon, triangle, any polygon we have, we can be able to find the measure of all the angles combined together. So a really easy one that we know is we look at say we have a triangle right here. We have a triangle, and we know a triangle, and we've learned this before, is 180 degrees when I add up all three of the interior angles. Well, if I know that there are three angles right here, if I put this into my formula, let's see what we get. 3 times, that should be 2. 3 minus 2 times 180, which is going to give me 1 times 180, which is going to give me 180, which is already what we knew what a triangle was, though. So this formula is going to allow us to find the sum of maybe some different ones that we don't already know. So like even if we know a quadrilateral, like a square or a rectangle, 4 sides, that should be straight. But we know a quadrilateral has 360 degrees because this is like two triangles cut in half. And so if I were to put this into my formula, I do the same thing where I get 4 minus 2 times 180, which is going to be 2 times 180, which again is like two triangles, which is what we have right here, two triangles, which is going to give me 360 degrees, which is something that we already know. So this is being able to find the sum of the interior measures. Okay, so make sure you have that formula written down, and we'll go to our next key concept. So our next key concept is corollary to the polygon angle sum theorem. So we can be able to find out the total sum of each one, and we also have a formula to be able to figure out the measure of each interior angle. So we take the angle measure, how many sides there are, minus 2 times 180, and we just divide it by the number of sides. But this only works for a regular, super important, regular polygon. Okay? So let's talk about and let's show you what a regular polygon looks like. Alright, so let's have you write down these 3 pictures with the vocab right here. So you're going to write down all these 3 right here. So we have different types of polygons. A polygon, an equilateral polygon, is a polygon with all congruent sides. An equiangular polygon, you see, has all the angles are the same, are congruent. And a regular polygon, this is the one that we were talking about right now, is a polygon that is equilateral and equiangular. So it's these two combined together. So when we are using our corollary to polygon angle sum theorem, it only works for these regular polygon where they have congruent sides and congruent angles. So when I'm using this one, it only applies to a regular polygon. Okay, alright? Alright, and our last key concept right here is we're going to be talking about exterior angle sum theorem. So before we were looking at interior, this time we're looking at exterior, so the outside. And the sum means all of them combined together. So what's really cool is that when we take each of the exterior angles and we add them together, they are always going to equal 360 degrees. So when we take, say like right here, if we add up these 5 right here to this pentagon, all 3 of these right here are going to add up to 360 degrees. So it doesn't matter if we have a hexagon, pentagon, triangle, quadrilateral, any type of polygon, when we take the exterior angles and add them together, they're always going to equal 360 degrees. Okay? Alright, so let's do a few problems now. Alright, so our first problem here, problem number 1, and it says, what is the sum of the interior angle measures of a heptagon? Alright, so the first thing is we got to know is, what is a heptagon? Well, we know it's a polygon, and we think a triangle has 3 sides. Quadrilateral has 4 sides. 5 sides is a pentagon. 6 sides is a hexagon. A heptagon right here is going to be 7 sides. So we know it's 7 sides, and we want to find the interior angle measure. We just got to remember our formula, which is n minus 2 times 180 degrees. Remember, n is just the measure of is the angle, how many sides there are. So if we know a heptagon is 7 sides, then we know that n equals 7. So this is how many sides is, and all we're going to do is we're going to plug that in for the n right there. So this is going to be 7 minus 2 times 180. So 7 minus 2 is going to give me 5 times 180. And when I do that, I'm going to 5 times 180, which is going to give me 900 in its degrees. 900 degrees. So we know that a heptagon, when all the angles added together and the inside of that polygon is going to equal 900 degrees. So pretty easy if we remember the formula and if we can know how many sides there are in that polygon. Okay, let's go to our next. Alright, so problem number 2 that we have right here, it says that a common housefly, whatever that is, has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon. So we want to know what is the measure of each interior angle. So before we were finding the sum, this time we want to know each, though, of the interior angle in one hexagonal facet. So it looks something like this, but let's, if I were to draw what a hexagon looks like, it would look more like this. And so we are now trying to find out how many degrees each of these angles is. So we know first that there are 6 sides. So we know that my n is going to equal 6 because that's how many a hexagon is, or I could just count right here that there are 6 sides. So my formula to find each interior one is the same as the sum, where I do n minus 2 times 180. Whoops, I'm sorry. N minus, getting ahead of myself right there. N minus 2 times 180 degrees, and when we want to find each interior one, we would take this and divide it by n. Remember, we can only do this though if it is a regular hexagon. So that's super important. If it wasn't a regular hexagon, we wouldn't be able to find out each interior angle. Okay, but it did tell me it was that. So now I know that there are 6 sides, so I'm just going to plug this into there. So I'm going to get 6 minus 2 times 180. So this is going to be 4 times 180. And I got my calculator right here. 4 times 180 is going to be 720. So that is how many, that's the whole sum of it. But if I wanted to find each angle, I would divide this by how many sides there are, and there are 6 sides. So when I divide 720 divided by 6, I know that each angle in this regular hexagon is going to be 120 degrees. Okay, so it's my same formula for the sum, but when I'm trying to find each interior angle for a regular hexagon, I would just divide it by the number of sides, which means that each side right here is going to be 120 degrees, and they would all add up to 720. Okay, alright. Alright, and so this problem right here is we are trying to find what the measure of angle y is. So this one right here, in this pentagon of this right here, of today, just spells out today right there. So we're trying to figure out this one right here. Well, it's not a regular pentagon because each of these angles aren't the same. But we know a few things about this, so we can figure out how many degrees this total pentagon is. So I'll just kind of, you don't need to write down the words right here, but just write down this right here. So if I take each of these angle sides, and if I add them together, they're going to equal how many degrees a total pentagon is. And how can I find out how many degrees a pentagon is? Well, I can remember it, or I can use my angle sum theorem right there. So from here, all we are going to do is, we know that there are 5 sides to a pentagon. So I'm going to do 5 minus 2. It's going to give me how many degrees a total pentagon is. So from there, if I substitute each of the degrees for each one of these, they're going to equal the total amount. The only one I don't know is y right there. So I filled in all these right here, and now I'm just going to solve for y. So I simplify. So when I add up all these together, I get 470. 5 minus 2 is 3. When I multiply that out, that's 540. So the only thing I have to do to get y all by itself is I'm going to subtract 470 to both sides, which is going to give me y equals 70 degrees. Okay? And that's how we'd be able to find it. So usually for some of these we'll start knowing off the bat how many degrees a pentagon, hexagon, how many they are, but you can always find them with your angle sum theorem. And once we found that, all we had to do was find the missing one, and we know that when I take all the angles, add them together, they're going to equal 540. The only one I didn't know was y, so when I subtracted both sides, I can get that angle y all by itself. Okay. Alright, our last problem right here is, it says, what is the measure of angle 1 in the regular octagon at the right? So, biggest thing first is it told me it was a regular octagon, which means that each of the sides are going to be the same. And we know that these aren't interior angles because they're not on the inside, they're on the outside. So we know that exterior angles all add up to 360 degrees. So when I take up these 8 sides and they add up to 300, they add them all together, they're going to equal 360. Well, we know that since it is a regular octagon, each of these angles are all going to be the same. So all I have to do is do 360 divided by 8. That's going to give me 45 degrees for each of them. So if I was trying to find out what the measure of angle 1 was, it would equal 45 degrees. 45 degrees. We'll just underline it right there. And that's it right there. So thanks for watching, and we'll practice these soon.